Hello, and welcome to the session on security at scale with AWS partners and AWS services. My name is Samir, and I'm a principal architect on the partner team. And I work with security technology partners to help build new products and services on AWS. And this enables our customers to run their workloads more securely. The session hopefully will focus on considerations that will enable partners to build security products that scale for our customers. And we'll discuss a few areas, including identity, compliance, and strategies to build security tools on AWS. I'll touch upon some of the examples that our partners have built solutions on using AWS services, and also consider different scenarios where it can be applicable, whether you're utilizing the same AWS services or building something new off of it. So let's begin with why we're all here. We know that security is job zero for us at AWS. And our customers have an extremely high bar on how we handle their data. And we want to ensure that our customers are also confident running their workloads on AWS, irrespective of which services they choose to use, whether that's an AWS service or something that's delivered by our partners. And so what that means is every service and product needs to ensure the integrity and privacy of our customers' data. And this makes them comfortable to run their workloads on AWS. And so we as a group here are acutely aware of the need to focus on ensuring the security of this data. But APN programs themselves require that partners implement and do security well. And this enables customers to bring their workloads onto AWS environments. And we take these considerations in things like our competencies. Now, the other thing that we're also aware of, and what's become really apparent over the last 18 to 24 months, is that customers want to be able to move fast, to migrate, modernize, or build entirely new things. And they want to do this while maintaining the security of their workloads. And what this means is security cannot be an afterthought. It has to be built in from the application development life cycles, and with a framework that allows for monitoring and alerting while also allowing for swift and automated remediations. And this can be enabled and done using highly contextualized data that would allow for these quick response times. And so finally, what we also want to do is to help you move faster. We want to make sure that partners have the right tools and capabilities that allow them to help our customers to build secure workloads on AWS. So why are we here, and what should you take away then from this session, and what can you expect from it? First off, our customers are trusting their data and providing their access to AWS environments. And what that means is we need to do everything possible to ensure that customers are able to feel and are aware of all of the security mechanisms we put in place to secure their data. And we'll touch upon how and what customers expect off of that. The next thing that we'll sort of touch upon, and we won't delve into every AWS service, but what makes some of the scaling possibilities happen alongside AWS services across customer environments. And so we'll provide pointers so you can take back and leverage, and also provide examples of how some of our partners have leveraged these services to scale the security tools across many accounts. And finally, we also want to make sure you have a better grounding on how to build and design principles associated to allow you to create security policies and frameworks and controls that allow you to scale your security tools faster. So let's start off then with what customers want. Like I said, what's become clear over the last 12 to 18 months is the need for customers to empower their developers and move quickly. Being technology first has become extremely crucial, whether you're a consumer brand or serving other businesses. And speed and being able to quickly iterate then matters a lot. What this means is customers may have teams of specialized developers that have access to multiple AWS environments using a swath of AWS services that cater to their specific needs while spanning across geographies and that have their own regulatory and compliance requirements. Which brings us to their need of having the ability to create security and compliance controls across this real estate. From being able to create preventive and detective measures to being able to clearly answer questions for their business owners, auditors, and governments, and whether they're following compliance and regulations that their business requires, and also ensuring things like data residency requirements, the privacy of customer and developer data, and all of the data that resides or is persisting or transiting across AWS services. What this also means is that customers want to be able to act on implementing these controls in a consistent and automated fashion. They want to do this by also putting into place frameworks that allow them to quickly take action on security events and use mechanisms that effectively identify and enrich things so they are able to operate in a fashion that has enough context to take the right decisions. And this allows teams to not be burdened with activities that are considered to be lower risk and that don't impact applications or even enable individual development teams to fix their particular security risks. And this all starts off by identifying the security responsibilities between you, our customers, and AWS. I'm sure most of you have seen this slide before, and it sets a lot of the foundations for what we're going to discuss today. AWS takes care of what you see in orange on the slide here, and this includes the security of the infrastructure and the software that powers this infrastructure and our services. Customers are then responsible for this blue portion, which includes everything from identifying how you protect data at transit and at rest, how you're going to monitor and audit your access mechanisms, how you're going to perform activities like vulnerability management and patching, and also ensuring that you have the right access controls in place to safeguard services and data across regions and across applications. Now, these responsibilities, though, have evolved with the introduction of things like containerized services like EKS for EC2. You're no longer responsible for a bigger portion of these responsibilities. So customer responsibilities will now focus more on how users and machines access your data and how they use them. And it further reduces when you use abstracted services like AWS Fargate and AWS Lambda. And customers need to focus primarily only on the data access and the governance of that data. So if you put all of these service types side by side, you'll observe that as you move towards the right, there's less responsibility for the customer, but also there are more best practices built in. So then how do you tailor your security functions to address all of these different types of services? We start off by being able to provide the right set of permissions for you to use, and we do that with identity. So let's talk about that a little bit more. And why talk about identity, right? And what customers really care about is who has access to where and what are they allowed to do. Customers care about this for every single thing they put on AWS. If you come to think of it, whether you're a user or a device or a service, your identity dictates what you have access to and the operations you can perform on AWS. So identities become a very critical piece of a customer's overall security journey, and they're very different from other perimeters where previously you might have used things like IP addresses to control access. What I've also observed that is a lot of us, me including, focus on ensuring we set the right identity boundaries. But how many times do we actually go back and verify if they are too permissive? And do they need to be refined? If it wasn't for a password manager prompting me to rotate my passwords, I am fairly certain that I would have probably never changed my passwords. And that's something that I don't want to admit to. But having a strong identity strategy serves as an extremely good base to build upon for your overall security strategy. So the three things I want everyone to then think about as they build their identity framework is to ask, how are you setting permissions? So in other words, are the permissions for my identities tightly coupled with the users and services that need access? Uh, you periodically verify both the risk that these permissions expose as well as if there are the appropriate amount and refine them if necessary to suit the infrastructure applications and user personas as they change. So with that said, the three actions of being able to set, verify, and refine your identities enable you to maintain good identity hygiene. But let's focus on a little bit of the set aspect that we know very well. The concept of least privilege is a drum that has been beaten for a very long time. However, it becomes specifically critical when you have multiple entities accessing a shared resource. While most of us are aware of this, sometimes you get into situations where they're not implemented the right way. What's not least privilege, for example, is someone setting up just one identity that can be accessed by an entire team of developers. And what this results in is you start running into issues where you can't audit for changes within an environment and can't answer the question of who did what and when. So while you're going to be defining permissions, you also need to focus on the need for things like long-term access keys that are tied to users. And there might be cases where you would need long-term credentials, but there are also mechanisms that allow you to secure them and retrieve them in a better fashion. So short-term credentials, though, have multiple benefits. First off, they are short-term. You do not have to rotate or revoke them. And once they expire, they can't be reused. So even if someone gets a hold of a token, there's not much they can do. If you must use long-term credentials, though, ensure that you're thinking about, services that allow you to use them in a fashion that makes it secure. Think about things like Systems Manager Parameter Store or Secrets Manager that enable these sort of tools to work appropriately. So when planning then for identity and access management, you need to consider how you need to authenticate and authorize an action and how you do this at scale. Whether you're granting thousands of users across hundreds of groups just the right sets of permissions, or allowing for multiple sort of machines to access a shared set of resources. And so federation allows for a common approach for building sort of a mechanism to offload the responsibility of authorization and access control to an identity provider, and allows you to bring years worth of fine-tuned permissions and apply them across AWS accounts. So here are some of the AWS services that go into sort of areas that can enable you to do a lot of these practices. I won't get into each one of them, but in general, one of the examples that I often talk about is you can use things like IAM Access Analyzer alongside things like CloudFormation templates and an open source tool called CFN Policy Validator, which allows you to run existing IAM access policy validation checks against the CloudFormation templates. And it allows you to surface access policies that AWS considers a security risk because those permissions are overly permissive. Now, as you expand on the permissions themselves, you have to ask yourself whether you're refining and verifying these permissions periodically. And one of the simplest things you can check for is what resources are being shared externally. And externally can mean different things. But in this case, I'm specifically talking about whether a resource is shared publicly or outside of an AWS account. The next thing you want to do is have some sort of a tagging strategy. The most successful tagging strategies enable you to effectively create business relevant tag groupings, and the attribute themselves should enable you to understand and reason about these permissions. One other advantage that it provides is that it allows you to create granular permissions without having to update every single entity. Now, some of the other things you can do to verify these permissions include things like auditing for unused roles. So periodically going and verifying when a role was last accessed, the set of actions that it took. Also enables you to do things like controlling how much of a drift there is with the permission sets you've defined, and a drift on the number of users and roles that exists within an environment. And you want to continue iterating on the same framework so you're able to continuously tighten access to those permission sets. So in that regard, customers also want to manage single sign-on access to all of their AWS accounts. And in an organization where you can centrally manage access and user permissions. You can do this by using AWS SSO, and partners like Okta, for example, work with AWS SSO to allow customers to set permissions on a very granular basis across AWS accounts. Working with AWS SSO allows customers to then have all of their identity controls and rules in one place alongside with Okta. And you can sync attributes between these two entities and have a consistently tagged environment if required, and update changes to those policy permissions on the fly. So one of the things you can do is, for example, remove a user from an Okta group, and a workflow is triggered that invokes the right set of APIs on the AWS SSO side to remove the specific set of entitlements that are granted to a particular user. And while this is one example, there are many partners that fit into the same framework, including folks like OneLogin and Ping Identity. But what really this enables customers to do is to automate their identity security and enable a stronger identity foundation. So foundations then become very crucial, like we discussed, and identity plays one big part of that. But let's quickly just define some of the characteristics that make a good foundation, because a lot of the same characteristics apply to a good security foundation. So security first cannot be an afterthought. It has to be the first consideration you have when you build something on AWS. It has to enable you to build and scale anything on top. And the framework that you put in place should provide durability and resilience under all conditions. AWS itself has a lot of best practices built in, enabling you to start off on a strong foundation. And one of the ways we help customers be more secure, and I strongly believe this, is through our APIs. Every AWS service you interact with, if you think about it, whether you're creating resources, reading, or updating attributes, are backed by an API. What's also really neat is that each one of these API calls is encrypted, authenticated, and authorized. Now, if you take a minute to think about why that's important, there's nothing in our API infrastructure that takes into account if a user is coming from a secure private or a completely public network. The API keys allows us to uniquely sign every request, and it allows our customers then from anywhere in the world to securely interact with our services. And this is all over the public internet, across millions of API calls, across all AWS accounts, all services, and in all regions. What it also allows is to easily discover resources in your AWS account. And if you consider the elasticity of the workloads that you deploy in AWS, this becomes a very valuable asset to have. And we expose a rich set of described API calls that allows customers to do really neat things like having something like a real-time asset inventory that is kept up to date always in near real time. Having this real-time inventory and the ability to listen to changes in this environment also allows you to use API to orchestrate changes at scale. And so event-driven architectures take advantage of this and allow you to automate various aspects of how you operate your workloads on AWS. Now, with that said, because you're able to discover, monitor, and orchestrate changes, what you can also do is things like read and audit changes related to the configuration of your assets and evaluate if they're set appropriately. And so, how then can you use APIs to specifically get better security outcomes? Because you're able to discover assets, monitor changes, and audit configurations, one of the things you can do is to evaluate security risks and implement good security baselines for an asset, service, or an AWS account. And this can be done by using multiple APIs, and you need to consider these evaluations as point-in-time snapshots of security risks, and there is going to be a need for you to continuously both evaluate and evolve these baselines over time. Customers should then consider services that enable them to achieve this, whether it's an AWS or a partner solution or some combination of both. You can also build detective and preventive controls and monitor anomalous activity in order to satisfy compliance needs. But you can implement detective controls like either monitoring for a role that's suddenly using or making API calls in a specific region, or even create detective controls like putting in place the right set of security groups or the use of the right set of AMIs for your workloads. Now, what I also want you to consider is tying together the resources accessed, the actions performed, and the patterns of access together. What this enables you to do is to correlate these attributes with metadata, so you can easily enable reasoning on top of this, which allows you to answer the question of who has access to where and what, and doing that quickly. And finally, with services like AWS CloudTrail that provide the ability to archive all API calls, customers can permanently store their API events as logs that enable them to be used for audit and incident response. So, how can partners aggregate these API calls and identify security event data that is associated to anomalous or malicious activity? You start off by some method of access into a customer's account, typically using some sort of a cross-account role that can be deployed via a CloudFormation template. And one method of gathering CloudTrail events is by using EventBridge, which allows for a serverless mechanism of building event-driven architectures and an event bus that has a pub-sub sort of architecture to enable you to build a very scalable mechanism to process thousands of CloudTrail events in near real time. So with the cross-account role and the right permissions, what you can also do is gather additional metadata and verify the state of a resource should a customer ask the question. And EventBridge also then supports all of the abilities to target multiple AWS services to perform some sort of an action off of it. So for example, you can trigger a function, a Lambda function specifically, that can enable you to do interesting things like filtering for specific events, do stream processing, or writing to S3 for long-time archival. But one of the challenges that becomes apparent is that trying to deploy this across thousands of accounts, across many customers is a big challenge. So then how do you think about AWS accounts, and are they the boundary for applications, which they are quickly becoming, and customers then end up moving from a few, maybe tens of AWS accounts to thousands of AWS accounts as they build more workloads on AWS. So it then becomes even more critical to implement compliance and governance at the account or even organizational level, as one compromised account can have potentially an extremely large blast radius. One of the ways that AWS helps customers build a strong foundation for both identity and account governance is via AWS Control Tower. Now, Control Tower allows you to set up a multi-account AWS environment with best practices built in. And this is in addition to other things like federated access and centralized logging. But by enabling things like automated account provisioning with best practices built in, and things like guardrails, which can both have preventive and detective measures, customers can quickly provision secure AWS accounts for all of their development teams. And this is with baselines that are customized to suit the regulations that they require for their organization. What this also ensures that every AWS account has the same set of baseline permissions and controls in place, and allows you then to build upon those detective and preventive controls. There are a set of mandatory guardrails that always come with Control Tower. So, for example, a mandatory preventive control is something like not being able to delete the log archive. And we have a few other guardrail types, including things that are strongly recommended guardrails and sort of ones that you can choose to implement. So for another example of a strongly recommended guardrail is to ensure that you're detecting whether a security group has SSH open to the world, for example. What you can also do is get visibility into whether all your accounts are adhering to the compliance requirements by checking their status against these guardrails. You can easily subscribe to an SNS topic that can then allow you to receive the compliance notifications or the change notifications to compliance events, and receive it as an email sent to the audit account, which Control Tower provisions as well. So where are areas you can work with Control Tower to scale security capabilities? Customers now can easily log everything centrally. So this includes API events, OS logs, network and application activity. And so consider how you can enable your security teams to use these mechanisms to ensure the long-term retention that may be required for both compliance and audit reasons. Now, guardrails are also implemented through service control policies and AWS config rules. An SCP, for example, is allowing customers to limit certain actions that they can perform across an organization and is applicable for every account that is part of an OU. And so, if with a combination of both SCPs and IAM permissions, you get a set of permissions that allow a user to perform a very prescribed set of actions. The other thing that you can do with Control Tower is, when customers ask you how to set up their AWS environment effectively, you can use sort of these unified set of recommendations that we typically call as multi-account strategy to implement controls across the organization. So Control Tower is almost like a control plane that sits on top, orchestrating multiple AWS services across AWS accounts. And it also provides you the ability to take advantage of that orchestration mechanism to enable you to build better security functions. Now, with Control Tower, you can also start creating workflow automation. So you can do things like creating and setting up security tooling and monitoring during account generation. And you can ensure you have visibility into the actions performed in an account from the very beginning of the life cycle of an AWS account. And this is achieved via a combination of both provisioned IAM roles that exist in every AWS account that Control Tower provisions, and a set of mechanisms that notify you of changes or events that have completed, called lifecycle events, that control tower emits. And so those events include things that can be interesting to you, including things like where the region where the call was made from, the OU name and ID, and also the account name and account ID that you can then use to generate, workflow automation. Now, when you think about centralizing logs contain a wealth of information to help you reduce exposure to security risks. And if they're continuously monitored and acted upon, it enables you to use this logging strategy to become a very critical component of your overall security strategy. Guardrails enable you to stop or detect things from happening, but however, you'd also like to know at any point in time what is happening within an AWS account and to monitor and detect for anomalous activity. This multi-account structure allows you to send logs and configuration information to a centralized log archive account. And this design enables the log archive account to centrally store, protect, and analyze sensitive log files across all of the AWS environment that you use. What you see here are a few examples of things you would monitor within an AWS account. So things like all of the security logs, whether that's from different AWS services themselves or the workloads. You can monitor across different types of environments like prod and dev, and you can sort of monitor things like shared services as well. What this brings us with everything in place is how do you then develop your workflow automation? It starts off by having this standardized cross-account access that we talked about, and having the consistent set of permissions that allows you to do different actions within each of those AWS accounts. So these predefined IAM roles that are present allow you to assume role or sort of federate into an AWS account and perform a set of actions that either allow you to set up security tooling or perform remediations. And having a standardized set of access mechanisms also enables you to only package the deployment once, set it, and then forget it, because you can then scale across all of these member accounts in combination with things like lifecycle events. And what this means is it enables account governance and customizations to what you can do when an AWS account is being generated by Control Tower. And so you can do things like triggering a Lambda function that can perform certain actions. You can send this event into a simple queue service, enabling you to have security teams or audit teams take a look at all of the events that are happening. And EventBridge also supports the ability to directly send this eventing data to an API endpoint. So if you're a monitoring service that already has an API endpoint defined, you can use EventBridge to directly send all of the CloudTrail events or the Control Tower lifecycle events directly to your API endpoints. And so you can use security solutions from one of many partners that we have as part of the Control Tower sort of solution that enable you to get security and insights into your AWS accounts right from the start. And these solutions all use some sort of combination of, again, lifecycle events, using the multi-account structures and automation to enable these use cases. Now that you sort of have a good identity and framework to build tooling into your workloads, how do you then enable additional strategies to detect anomalous behavior? And one of the areas where you can also focus your efforts are on identifying anomalous network activity. And some of the strategies you want to think about are whether you want to look at network activity and evaluate it for a point in time sort of detection, or do you want to perform anomaly detection over a range of data sources, whether that's just flow logs from AWS or actual packet captures you're getting from instances? This will then dictate whether you want to put in place network detection capabilities in line with traffic, or sort of have a passive mechanism to enable detective controls on top of that network activity. And you can do things like correlating this information of things like known bad IP addresses and disallowed regions with the logs and data you're collecting from your network information itself. And finally, your detective strategies for networks itself have to be extremely application dependent. So for example, if you want to do things like passively inspect and not have to have sort of inline capabilities, you might be using things like flow logs and traffic mirroring to enable these sort of detective strategies. But if you want inline and you want to enable things like application based application vulnerability based detections, then you'd use something like a WAF, or preventing sort of malicious events from happening by using things like AWS Network Firewall. But what it also allows you to is to build a framework where, with the collection of metadata that you have alongside all of this network activity, you can almost create a graph of information that correlates what entity is talking with what network resource, and you can easily then understand and reason about why is it that this is happening. So finally then, moving on to how do you enable customers to then scale their remediatory functions once they have all of these detective and preventive controls in place. It becomes extremely important to discuss how you can enable customers to take action. One of the first things you want to monitor for is the API activity itself. We discussed how APIs are sort of the gatekeeper and allow you access into multiple AWS services. So tracking specifically what is being called and what actions are being taken becomes a crucial part of evaluating whether you want to remediate a potential event. Other things you want to also take action for are when things become non-compliant. So let's say you have a developer that isn't aware of how you might have security groups that are moderated and need to be used across all workloads. And so identifying non-compliant resources and remediating them allows you to reduce the risk within your application framework and across AWS accounts. What you also want to do is, as you identify anomalies across both API activity and network activity, you want to be able to take action based off of that as well, by either triggering workflows that alert security teams, or enable remediations that quickly shut that resource away from the actual malicious resource. And finally, you have the detections that come from multiple security services, whether that's an AWS service like GuardDuty or Macie or Inspector, or from partner capabilities that do inspection across all of the different domains we spoke about. So how do you enable remediations then? How do you effectively create workflows that will enable customers to move quickly and stay secure? The first is around how you want to ensure that you test your response workflow. The very first time that you test the remediations you put in place shouldn't be at the time when you have an actual incident. So ensuring that you have some sort of mechanism to continuously evaluate how your responses to incidents are built becomes extremely crucial for very large scale customers. And think about what you can automate. Things like enrichment of data, quarantining certain resources, or even potentially shutting down or moving an instance to a state where it doesn't have access to either the data or the network, allows you to sort of remove the security team from having to look at each and every alert, but give them the time they need to go do their investigation while the security of the workload is still secure. Other things you want to do are classifying your risk, your data, and users across multiple dimensions. So think about, whether your data has personally identifiable information, has things like card data. Think about your users. Are they in different geographies? How do you enable both mechanisms to alert and remediate based off of the classification of these different entities? And finally, with the ability to have context-rich data, you can then create remediations which are very specific and tailored to the exact conditions that triggered that particular event. So one of the ways that you can enable centralized logging of all security events and take action is through things like AWS Security Hub. Security Hub not only enables you to centralize all of the different logs from AWS security services, but also allows partner solutions to both send findings to Security Hub as well as pull and enrich findings that are sent by other security services. But what should you be doing once you have all of these logs? You need to be able to remediate and take action based on the severity of the alerts that come in. Security Hub integrates directly into CloudWatch events and Amazon EventBridge, which means you can trigger multiple types of remediation workflows across a vast set of AWS services. So you can think of triggering workflows where you enable a Lambda function to go quarantine a resource. You can use Systems Manager to trigger remediations that are specific to what you need to be doing inside of a host, or you can send it directly to a Kinesis Firehose that allows you to then send it off to either an archival sort of workflow or enables you to sort of do things like stream processing. Now, one of the challenges though is, you have multiple accounts and you scale across regions. How do I then centralize all of the logs coming from all of my accounts across all regions? And so Security Hub now has this concept of cross-region aggregation, which enables our customers to centrally log all of their security findings across regions, across accounts in one single place. The way we do this is by enabling customers to set some sort of a home region, which acts as the region that has all of the aggregated data. And on the back end, what we do is make the appropriate API calls to both import findings and update them in the aggregated region. One of the other cool aspects of this doesn't change any of the current frameworks you have in place to set up Security Hub and how it's functioning. Security Hub with aggregated findings set up will automatically take all of the region's findings and move it into the aggregated regions, which means you don't have to make a lot of changes to both the alerting mechanisms as well as the remediation mechanisms. What you might need to do is essentially move how and where you start creating your workflows to remediate from. So where do we go from now? Hopefully, what we've sort of come to learn about is that you have the abilities to concentrate and help customers on their identity journey as part of their overall security strategy. We've discussed mechanisms that allow you to scale your security functions across AWS accounts and environments. We discussed a few AWS services that enable you to make these different strategies possible. And hopefully you got some perspective on how you can take action on security alerts. Now, where you also want to concentrate your efforts on is to identify, some of the partners that can help you on your journey on enabling customers to be secure on AWS. And you can explore solutions from a wide variety of security partners that go from securing your network and infrastructure security to protecting identity and providing access controls around it, to vulnerability and patch management, to logging and threat detection. And so where do you find help to evaluate these sort of requirements? Well, you can go to the APN portal, for example. You can speak to us, your partner solutions architects. And of course, you can always go read up about AWS security services and use your AWS partner and security booths as part of reInvent to go chat with the experts as well. With that, thank you very much for taking the time to join me to discuss, security at scale with AWS services and APN partners. I look forward to seeing all of you next year. Thank you.